Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I will explain you the block diagram reduction rules in the control system subject. Let me go to the lecture. Normally, a block diagram is a pictorial representation of the behavior of a linear system. So here is the definition. A block diagram is a pictorial representation of the functions performed by each component and of the flow of signals. And some of the elements, then I will tell you some of the elements which are used to draw the block diagram. First element is block. The block may be system element or may be feedback element. Normally the system element will be represented by the block like this. This G represents system gain. Okay, so here I have given input as R. If the output is given as C, then we can find the C as R into G. That means product of input signal flow and its system gain. Okay, and its system gain. And then the feedback element will be represented by the term H. So input here I have represented as C and output signal flow I have termed as B. So if you want to find the output signal flow for the feedback system element means same formulation only, B equals input signal flow into that gain. So it will be equal to CH. Okay. The next element is summing point or adder. This summing point is used to compare the signals. It can be used to add the signals or to get the difference of signals. So here is the summing point. Normally it will be represented by a circle with the combination of positive and positive operator, otherwise positive and negative operator. So here first I have given positive and positive operator, and here I am giving one input signal X and other input signal as Y. Then the summing point output signal flow will be equal to the summation of two input signals X plus Y. Okay, and then otherwise this summing point can be represented with the combination of positive and negative operators. Okay, which is used to get the difference of signals. So here I am giving X and Y as the signals. So the output signal flow will be equal to X minus Y because negative operator is here for the Y input signal. So X minus Y, this is the difference of signal. So using the summing point, we can get the addition of signals and we can get the difference of signals. Next one is branch point or otherwise termed as takeoff point. So normally branch point can be taken out from any signal flow. It can be taken out from input signal flow or intermediate signal flow or output signal flow. From any branch we can take out that takeoff point. So here I have given one block which consists of input signal flow and output signal flow, and here I have represented takeoff point from the output signal flow. Branch point is taken out from the output signal flow. So if the input is R and if the output is C, the branch point is taken out from the output signal flow. So the branch point output will also be equal to C only. Okay. So this is about the three elements which are used to draw the block diagram. And next one is block diagram reduction. So normally a control system can be represented by multiple blocks. Each block represents element. Each block represents system element. Okay, the multiple block diagram can be reduced to a single block diagram which represents overall system gain. Okay, single block represents overall system gain. So to find the transfer function, the block diagram reduction rules to be followed. The first rule is feedback control system. Elimination of feedback control system. There are two types of feedback, negative feedback and positive feedback. First I will tell you about the negative feedback control system. So about this feedback control system, already I have given the lecture. You can go through that. So this is a negative feedback control system. It consists of system gain G of S and feedback system H of S, and R of S is the Laplace transform of input, C of S is the Laplace transform of output. Summing point compares the signals and it adds the signals and it will be given to the system element which processed and the process element process, and it forces to get the output. Okay, and then it will be reduced to a single block which represents overall system gain. So this is a single block. After reduction, we got the single block which represents overall system gain for the negative feedback control system. G of S by 1 plus G of S H of S. This is the overall system gain for the negative feedback control system. This derivation is also given in the previous lecture. You can go through that. Okay. So shortly, it can be represented as C by R equals G by 1 plus C, 1 plus GH. C by R is nothing but overall system gain, or it can be termed as transfer function. Okay. And then about the positive feedback control system. So positive feedback control system, in the positive feedback control system, positive and positive operator combination is there in the summing point, and it adds the signals and to get the output. So this positive feedback also we can eliminate, and it will be reduced to a single block diagram which represents overall system gain for positive feedback. G of S by 1 minus G of S H of S. Only sign change will be there. So shortly it will be represented as C by R equals G by 1 minus GH. Okay. So this is about the elimination of feedback system. And then rule 2, block connections. Okay, there are two types of connection, series or cascade connection and parallel connection. So here I am considering series connection. Now I am giving G1 as one block and G2 as another block. Now two blocks are connected in series. I have given input as R and output as C. Let me find the output first. So here I have termed the intermediate input signal as B. Okay, let me find G1. G1 is the system gain 1. G2 is the system gain 2. So here G1 equals output by input B by R. G2 equals C by B. So when we multiply these two gains, G1 into G2 equals B by R into C by B. So here this B get cancelled. This B get cancelled and it will become C by R. So C by R is nothing but transfer function. So transfer function of the system. So for the cascade connection system, C by R equals product of gains. So it will be reduced to a single block like this, product of system gains G1, G2. So like that, if multiple blocks are connected in series means it can be reduced to a single block which represents the product of gains. Transfer function C by R equals the product of gains G1, G2. And about the parallel connection, G1 and G2, if G1 and G2 are connected in parallel using the summing point like this. So if we, here I have termed input as R, output as C. So if this is like the takeoff point, this is nothing but the takeoff point from the input signal flow. So same signal flow. Same signal will be flowing through this. R is given here. So R is given for G2, R is given for G1, and here this intermediate output signal I have termed as B, and here D. Okay. So after the summing point, what is the summing point output? It will be equal to C equal to B plus D. So here I have found G1. G1 as B by R and gain 2 is D by R. So C equal to B plus D. Now substituting for B and D, from this we can find B as RG1 and D as RG2. So substituting for that, C equals RG1 plus RG2, taking R as common, R into G1 plus G2. Now we can find the transfer function C by R equals G1 plus G2, which is the addition of gains. Okay, addition of system gains. When multiple blocks are connected in parallel, its system gain can be added. That is the meaning. It will be reduced to a single block which represents addition of two system gains. Hence transfer function equals C by R equals G1 plus G2 for the parallel connection. And then the next rule, shifting of adder or summing point. Adder can be otherwise termed as summing point. So adder may be shifted before the block or after the block. Okay, I will tell you how to shift the adder before the block and after the block. So here I am representing one pictorial representation which consists of block and summing point. So here I have considered one summing point and one block is given. R1 is given as input for the block, and then R2 is given as input for the summing point. Okay, so here this output of the block I have represented as B. So B equals input signal flow into gain, that is R1G. So R1G is given to the summing point and R2 is also given to the summing point. So here plus or minus operator is given. Okay. So output signal flow from the summing point I have termed as C. So we can find the C here. So C equals B plus or minus R2. So substituting for B, this will become R1G plus or minus R2. R1G plus or minus R2. So C equals R1G plus or minus R2. Now I am going to shift this summing point before the block. Okay. Summing point before the block such that its output should not be changed. Output should be maintained same. Okay. For that we should include some other block. So let me shift that. Output should be maintained same. So after shifting, first I am shifting that summing point before the block. So I have shifted the summing point before the block. Here I am giving input as R1 and another input for the summing point as R2. Let me find the output here first. Then we will include the block. Okay. So here if we find the output of the summing point, R1 is one input signal, R2 is another input signal. So R1 plus or minus R2. Okay. And then if we find the output of the block means this R1 plus or minus R2 is given as input signal flow. This is system gain. So it will be equal to R1 plus or minus R2 into G. So see this output. This is the output. See this output R1 plus or minus R2 into G. See this output R1G plus or minus R2. So this is wrong only. So this output is different from this. We should maintain this output. We should get this output. So to get this output, we should include some other block. What we can include? We can include reciprocal of gain. Reciprocal of gain 1 by G should be included to get the same output. Okay. So here I have included 1 by G and input is given before this. Okay. Input I have shifted here. R2 is given to the 1 by G block and after that we will get the output R2 by G. That R2 by G is given to the summing point. Now we will find the output R1 plus or minus R2 by G. So if we find the main output, C equals R1 plus or minus R2 by G into G. So if we expand this R1 into G and then R2 by G into G, that G will get cancelled. That expansion that will be reduced to R1G plus or minus R2. So see here, this output and this output is same. Okay. Now we got the same output. So for shifting the summing point before the block, we should include the reciprocal of gain. We should include 1 by G. Okay. And then how to shift the summing point after the block. So here I am representing summing point and block and I am giving one input for the summing point, another input for the summing point also. So here I have given input as R1 and another input as R2. First we will find the output. So if we find the output, here I have represented B. So B equals R1 plus or minus R2. And here main output is represented as C. So C equals R1 plus or minus R2 into G. So when we expand that, this will become R1G plus or minus R2G. Okay, R1 plus or minus R2G. Now I am going to shift this summing point after the block such that this output should not be changed. Okay, we have to maintain the same output. So for that we should include some other block. Let me find that. So here after shifting, first I am shifting that summing point and then I am giving the input R1. R2 is given as another input for the summing point. So let me find the output. So here output of the block is R1G and output of the summing point is R1G. R1G is given as input, one input for summing point and R2 is also given as input for summing point. So we will get the output as R1G plus or minus R2. So now compare this output and this output. This is different. So this is wrong only. We didn't get the same output. So to get the same output, we should include some other thing. Okay. So here we should get R1 plus or minus R2 into G. So now we can include the gain. Okay, we can include the G block. So if we include G block and if we give the input signal before that, so if R2 is given for that block output will be equal to R2G. Now summing point output, see the summing point output R1G plus or minus R2G. So see here R1G plus or minus R2G. Now output is maintained same. So to shift the summing point after the and next one, exchanging of summing point or adder. So if the system consists of multiple summing points, then how to rearrange that I will tell you. So here this pictorial representation consists of two summing points. I have represented two summing points and one block. So R1 is given for that and R2 is another input for the first summing point. R3 is another input for the second summing point and block is given. This is first summing point, second summing point. Let me find the output first. So this output is, here I have termed the output as C. We will find the C. So this output of first summing point output will be equal to R1 plus R2. Second summing point output will be equal to, this is one input, this is one input. So R1 plus R2 plus R3 will be the output of the second summing point. So that addition of signals will be given as input for the block. So that will be equal to, main output will be equal to R1 plus R2 plus R3 into G. That will be the main output. Okay. Now we can exchange the summing point such that the output should not be changed. Let me exchange first. Let me exchange the summing point 2 in the place of 1 and summing point 1 in the place of 2. Okay, now I have exchanged two summing points, second summing point in the place of 1 and first summing point in the place of 2. So I am giving the same input here. What is the second summing point input? Main input is R1. What is the second summing point input? R3. So R3 is given here. And what is the first summing point input? R2. So R2 is given here. Let me find the output. Here R1 plus R3 and this summing point output is R1 plus R2 plus R3. Okay, R1 plus R3 plus R2. So anyway, it will be the summation of signals. And main output I have termed as C. C equals R1 plus R2 plus R3 into G. Okay, so there is no inclusion of any blocks. We can exchange directly. That is the meaning. We can exchange the summing point directly. If the summing points are nearby, we can exchange to reduce the multiple blocks into a single block. And then next rule is shifting of takeoff point. So we can shift the takeoff point before the block or after the block. Now I am representing the takeoff point here. So R is given as input for the block G and then here the output signal flow I have represented as C. The branch point is taken out from the output signal flow. So that is equal to C equals, we can find the output R into G. So this output signal will be flowing through the takeoff point also. So the takeoff point output is also RG. Now what I am going to do, I am going to shift this takeoff point before the block such that the takeoff point output should not be changed and main output should not be changed. Okay, so we need to check both. Okay, for that we should include some other block. So now see here, first I am going to shift the takeoff point before the block. I am shifting the takeoff point before the block. Okay, first I have shifted. Here what is the main input given? R. If we take the branch point from the input signal flow, so what will the output of the takeoff point? It is R. So here, see here the takeoff point output is RG and see here R. It is coming as R. So something we should include to get RG. So we can include R into G is RG. So we can include the block. Okay. We can include the system gain. another block which represents G. Now we will get the output as RG. Now the takeoff point output is RG. So output is maintained same, and also the main output is RG. Okay. So to shift the takeoff point before the block, we should include the gain. And next one is after the block, shifting the takeoff point after the block. Okay. So here before the block I have given R is given as input, and takeoff point output is, we will find takeoff point output. So takeoff point is taken out from the input signal flow. So here also R will be flowing, and output signal flow is represented as C. C equals nothing but RG. Okay. So and now the takeoff point output should be maintained same, and main output should be maintained same. For that we can shift. Now we are shifting the takeoff point after the block. So I am shifting the takeoff point after the block. First I have shifted the takeoff point after the block. Let me find the output. Here our input is given as R, output is given as C, and from the output signal flow I am taking the takeoff point. So this output is also equal to RG. So what is output here? What is output of the takeoff point? It should be R, but we got RG. So RG should be, that G should be eliminated. So G should be eliminated. For that we can include the reciprocal of G. 1 by G block should be included to get the output of the takeoff point as R. Okay. So to shift the takeoff point after the block, 1 by gain should be included. And then next one is rule 6, rearrangement of takeoff point and summing point. So if the block diagram representation consists of summing point and takeoff point nearby, means we can exchange like this. Moving takeoff point before adder. So here, see here, now I am representing adder and then takeoff point nearby for this, in this pictorial representation, and block is also represented here. R1 is given as input, R2 is given as input, R2 is also given as input for the summing point. Then the output of the summing point is R1 plus R2. So from this output signal flow, I have taken the takeoff point. So takeoff point output will also be equal to R1 plus R2. Okay, now we can shift, now we need to shift the takeoff point before the adder. We need to shift the takeoff point before the adder such that this output of the takeoff point should be same. Okay, the main output is R1 plus R2G. This output and this output should be same. So now we are going to shift that. After shifting, after rearrangement, now I am shifting the takeoff point before the summing point. Okay, R1 is given as input, R2 is also given as input for the summing point. I have shifted the takeoff point before the summing point. Now we will find the output. So if we take the takeoff point from the input signal flow, this output will be equal to, output of the takeoff point will be equal to R1 only. But we should get R1 plus R2. So addition of R2 signal should be, that is R2 signal should be added. So for the addition of signals, we should include we can include one summing point. Okay, to add the signals R1 and R2. So we should include one summing point to get the output as R1 plus R2. Okay, now we will find the output here, output of the first summing point here. This is R1 plus R2, and here C equals R1 plus R2G. So main output and takeoff point output is maintained same. So moving takeoff point before the adder, we should include one more summing point to get the output of the takeoff point same. And then moving takeoff point after an adder. So here takeoff point is given before the adder, we need to shift after the adder. So R1 is given as input, R2 is given as input, given as another input for the summing point. What is the takeoff point output? It is taken from the input signal flow R1. So this output is also R1 only. And here main output, we will find the main output. This is R1 plus R2. The main output is represented as C. C equals R1 plus R2G. Okay. Now we need to maintain the output of the takeoff point R1 same. We need to get that output only. Now I am going to shift. Now I am going to shift this takeoff point after the summing point. Takeoff point after the summing point. Okay. See, I am shifting. Takeoff point is shifted after the summing point. R1 is given as input, R2 is given as input for the summing point, and takeoff point is shifted after the summing point. Now we will find the output of the takeoff point. So, so what is the summing point output? R1 and R2 are added. R1 plus R2. So from that input signal, that signal flow, takeoff point is taken out. So that takeoff point output will also be equal to R1 plus R2. What we should get? R1. We should get R1. For that R2 signal should be eliminated. So for the elimination also, for the subtraction also, we can include another summing point. Okay. We can include another summing point. So we can include the summing point with the positive and negative operator. So for the negative operator, R2 is given. So we to get the output as R1 plus R2 minus R2, that R2 will be eliminated to get the output as R1. Now we got the output R1. So here also R1. The output is maintained same. So for the rearrangement of takeoff point and adder, we should include one more summing point. Here also, here also. After an adder also, before an adder also, we should include one more summing point. And then I will summarize the rules. What are the elements? Summing point. First, about the summing point. If you want to move the summing point before the block, means we should include reciprocal of gain. If you want to move the summing point after the block, means we should include gain. We should include G. So whatever the block represents, that G should be included. And about the takeoff point, if you want to move the takeoff point before the block, means gain should be included. G should be included. And after the block, 1 by G should be included. Other reduction rules are shifting summing point before or after takeoff point. So if a summing point and a takeoff point are nearby, means if we should rearrange, means we should include another summing point with the possible operators. Okay, and then exchange of summing points, we can exchange directly without changes. We can rearrange that without changes. So this is, I have summarized the rules to reduce the multiple blocks into a single block, which represents overall system gain. So using the block diagram reduction rules, we can find the transfer function of the whole system. This is Mani's Gate Tech Vision. This is the channel for engineering lectures. Thank you very much. You can mail your queries to the mail ID dmoneylecture@gmail.com. Thank you very much.